Okay, exponential growth and decay. Um, you may or may have not been exposed to this while taking Algebra 1, kind of depending on the year. Anyways, A and B are numbers that can change. A is just like any other A value we've got, can reflect it and make it go wider, narrower, things like that. What we got here now is this B, this base. And it's exponential because the x is now in the exponent position. So now it's in the exponent position. And like we've talked about in the last couple units, it's okay to take and put negative exponents in, 0 and whatnot. So x is all real numbers. When it comes to range, though, when it spits out, you'll find out that the parent, or the typical one, has got a range of y is bigger than equal to 0. Or I shouldn't say equal to, y is bigger than 0. Because this graph is going to have an asymptote. And we've talked about those with a bunch of different conic sections. In this case, the asymptote is typically y is equal to 0. Okay, so in other words, it's the x-axis. Now, that can change if we move the graph up and down, left or right, things like that. We got two possibilities for exponential. We have growth or decay. When that base is bigger than 1, it's growth. If the base is bigger than 0 but less than 1, we've got decay. So this 8 means absolutely nothing in this first example. It's all about that 7. And since 7 is bigger than 1, it would be exponential growth. And the bigger the number, the faster the growth. Okay, since 5a is a sandwich between 0 and 1, we've got decay. Okay, and here, but oh wait, negative exponent, so what's that going to do to the base? It's going to flip it and make it 1/2 x and then the 1/3. So this one's actually decay as well. Okay, so we're going to take and talk mostly about the graphs. Just like we did with other ones, we're going to translate these. So we're going to put an h and k that's going to move it left and right, up and down. So for example, that 2 means that everything's going to move over 2 to the right. And that right there is going to move it up 1. So over 2 to the right, up 1. We're going to kind of move everything right there. So that asymptote that was at the x-axis got moved up to here. So y is equal to 1 is my new asymptote. And I'll set up a table for the parent function of 3x. And eventually I'll take those values and I'm going to multiply them by a 2. Okay, but I'll put in a -2, -1, 0, 1, and 2. And I'm actually going to start down here because 3 squared is 9. Well, the only difference between a -2 and a +2 is reciprocal. So that's 1/9. Okay, 3 to the first power is 3. So this one's going to be 1/3. And then 3 to the 0 power is 1. Okay, now this 2 is there just to make it grow a little bit bigger. So I'll multiply by 2 to get 2 9s. Multiply by 2, 2/3, 2, 6, and 18. Okay, so from my new spot, just like we did the other graphs, I'm going to go to left 2, go up 2 9s, go over 1, go 2/3, up to 2, over 1, and up to like 9, and there's your exponential growth. Okay, my domain is all real numbers. My range is y is bigger than 1. It's basically that number, just like it always has been for parabolas, absolute values. And what did we graph last time around? I'm blinking right now, but our square roots and cube roots. Okay, so again, here we go. Remember, it's opposite, so we're actually moving to the left one. Okay, opposites, we're going to move down 3. So down 1 over 3. And there is my asymptote. Oh yeah, and by the way, that gives it away for the range that y is going to be bigger than -3. And x is all real numbers. Okay. -2, -1, 0, 1, and 2. my parent function is 1/2 x. Okay, so I'm going to take and go with the bottom one again first. So 1/2 squared is 1/4. So the reciprocal of that, 4. 1/2 to the first power is 1/2. So the reciprocal of that is 1. And then to the 0 power is 1. I'm sorry, that should be 2 up there. Okay, and then again, because of that 3, I'm going to go through and multiply all those by 3. So 12, 6, 3, 3/2, 3/4. So now what it looks like is -2 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, somewhere up there. I'm going to go over 1 and up 1, 2, 3, 4, 5, 6. Okay, I'm going to go to 0, 3. Just counted, show you right there. 1 and 3.5, so 1.5, and then 3/4. So, looks a little bit different. Exponential decay starts off big and starts crashing down and gets smaller and smaller and smaller. Exponential growth starts off smaller and gets bigger and bigger and bigger. So, what happens if you put a negative value out in front? Well, does what every other graph does. It's going to reflect. So it is still technically exponential decay, and I don't know if I really care for the reflection versions of exponential growth and decay, because it starts to look like something else. We'll do a little bit later, not quite now. But that's going to give me 1/4 and 4, 1/2 and 2. I like to start with the positive exponents and then take the reciprocals. That's kind of how I fill up my table. And then we're going through and we're multiplying by -1. So -4, -2, -1, -1/2, -1/4. Okay, so I'm going to move up 2, but not over left or right. There's my asymptote. Alright, so from there I'm going to go over 2 and then down 1, 2, 3, and 4. Over 1, down 2. And look, something like this. So now your range of y is less than 2, and your domain is x is all real numbers. Okay, so hopefully that helps out. I kind of do this with the idea that you've done this a little bit before. Maybe you haven't. Maybe we need to go back and talk a little bit more about the actual parent function itself. But the idea is that, let's say I pick any base. So here's my parent. When I've got y is equal to, say, 2 to the x power. I can pick any number for x. And even though I have negatives that I plug into this function, the negative just means fraction. Okay, so none of these y values actually get negative. And even if I kept on putting like a -3, I just get like a 1/8, -4, 1/16. I'd get really, really small. I just never get to 0, and hence I got my asymptote. So hopefully this helps.